tomorrow. For those of you who are remembering. And you also should be remembering that you can make your own formula sheet for it. Because you have the formulas you wish. You may use formulas, you cannot write examples on your formula sheet. Any questions about that? So we look at back to 9.1. Oh, first, if I was doing something that was non-calculator. So if I'm saying non-calculator section, I'm not positive I'm going to do this or not. Would be maybe a couple graphs. This would be maybe a couple of polar graphs. I don't want to use the graphing capability. Now I'm not sure if I'm actually going to do that. And it would be something relatively simple, like maybe r equals 3, or theta equals 3 pi over 2, or maybe even a little bit more complicated, r equals cosine, or r equals say 2 cosine of theta. What that means is you may want to put on your calculator or on your formula sheet something like this. It says square root of 2 is approximately 1.4, or square root of 3 is approximately 1.7, something like that. Some of the common numbers that you use. Remember on the unit circle, those square root of 2, square root of 3 were there. I think there's only 2 on the unit circle that you can't deal with much. Now, as I said, I'm not sure if I'm even going to put a non-calculator section on this or not. Basically, it would depend on when I'm looking at it, how much time I think it's going to take. From the previous test, do you like the calculator or non-calculator better? What? Most of them when I have both sections, it seems that non-calculator went really quickly for most people. So, overall test. Section 9.1, do you remember what it was about? Polar point. So this would be, very likely, I'll give you a problem, and I'll say, convert it to rectangular. Or actually, maybe I'll do a couple problems where I say, do a whole bunch of things to this set of points. So maybe I'll give you something like, say, pi fourth, comma, say 3 comma pi fourth, and say maybe graph, convert to rectangular, and give 3 equivalent polar coordinates, where we have negative 2 pi, less than or equal to theta, less than or equal to 2 pi. So maybe I'll give you a couple problems like that where I say, graph it, find the rectangular thing, and find 3 more equivalent points. First, everybody know how to graph that. Okay, what do you do? What? Okay, so sine pi over 4, so that's right here, and go radius of 1, 2, 3. No. Oh, I was drawing it to mark that that's pi 4. So I should put the point in a different color to indicate. There's the point. I just drawing the pi 4th line. Okay. How do you convert that to rectangular? Remember the formula. X equals r cosine theta. Y equals what? R sine theta. So what is r in this case? 3. What is theta? 5/4. So what is cosine of 5/4? Root 2 over 2. Then we're multiplying times 3. So we have 3 root 2 over 2. Good. And sine, what's it going to be? Same thing to the 5/4. So 3 root 2 over 2. And that's just using these two formulas. We know what the cosine of 5/4 is root 2 over 2. And what about finding 3 equivalent? So we've already got one with a positive 3. We know we're going to have another one with a positive 3, and 2 of them with a negative 3. So if you're doing this, this is the first thing I would set up. Is I know I'm going to have one more with positive radius and 2 more with negative radius. So positive radius, if it's got positive positive, means it should be a positive. Is this angle going to be positive or negative? What? Think about it, if we had a positive one, can we have a positive angle that gets the same thing right here? Without going around beyond 2 pi? No, so we're going to have to go negative to still get that same spot. So how big is this angle? -7/4. Now, if we use a negative radius, means we're going to this point right here. What is the positive angle here? 5/4. And the negative angle here. Because we know we're going to have a negative. Yeah, negative 3/4. You see where this came from? So notice we have one where we have positive positive, positive negative, negative positive, negative negative. Yeah, negative 3/4 right here. Because we're looking at from here to this point. Because if we're going a negative radius, we want to be on the very opposite side. So 9.2, what was it about? And this is where we were doing some polar graphs. So something like r equals 3 sine of 2 theta. So how do you graph that either by hand or using a calculator? Okay. What would be it if we were wanting to do it by hand, but we're wanting to mark the points as we go around? Anybody know the easiest way to do that? What I would do is use the table. So let's actually do one with the table. The 3 sine of 2 theta. So I'm going to put that in here. 3 sine 2 theta. If I want to get to all the points that I'm going around, first, let's see what the graph is going to look like. Okay, so we've got the four things. So now, if we were actually trying to figure out how do we do this, how do we find enough points? The easiest way to do it, we're going to go to table setup here. Table start, we're going to say we want to start it at 0. And what are the marking circles, like on the circle graph I've given you, what are the markings going around? What are the units at? For the angles. If you remember, what do you should go by? Like what's the first angle on the graph? After 0, first angle after 0. Pi 12. Then it goes 0, pi 12, pi 6, pi 4, pi 3, 5, pi 12. So the convenient thing is just put pi 12 here. Pi divided by 12. And then we can just look at the table. Now, this means at the 0 angle, we're going to have 0 radius. At the pi 12th angle, we have a 1.5 radius. At the pi 6, and this just goes around your circle. Each one, 0, 0, pi 12, pi 6, pi 3rd, or pi 4th, sorry, pi 3rd, 5 pi 12, until we get to pi halves right there. And you can just easily graph those going around. Put a point, 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 and then continue down. That goes, that's pi halves, then you go to the next one, next set. And this gets you all points going around very quickly, and you don't even have to do each calculation individually. Do you follow what it is for that? So just put y equals, put the equation in, table setup, start it at 0, and put pi 12 here. Now, what would happen if I put, say, pi 6? Now, it's just going to follow around the circle, because we're going by pi 6. So it would be pi 6, 2 pi 6, which is pi 3rd, 3 pi 6. So if the graph is not very detailed, but it doesn't have all these little loops, like this one has several loops, you could just do pi 6 if it's just like a circle or something like that to get your point. Now, what we're actually doing if we do pi 6 is we're doing pi divided by 6. And those are the points we're looking for if we put in pi 6. Those are the only points it would find. If we put in pi 12, no, it's actually easier to find the thing with pi 12. But it would find you each one of these points it jumps to. But if you know the basic shape already, then you don't really need all the details. So doing polar graph, maybe, so we're saying graphing them, and maybe find intercept and zeros here. And the third thing here is symmetry. So what is a zero? One of the convenient things, if you're looking at the table here, where does it equal 0? It's like a 0, pi half, pi, 3 pi half. You continue down.
Where's theta equal 0?
Yeah. Or where is radius equal 0? It's not where theta equals 0, it's where the radius. Because that's when it's going back to 0. I should put in here also max radius. So just look at this. What would the maximum radius this could be? 3. How do you know? Okay, so maximum of sine is 1 multiplied by 3, 3. So if I put like a plus 4 here, what's the maximum? 7. Remember, if this is 1 times 3 plus 4. Well, not necessarily in this case. 4 increases the radius by 4. Remember, we're not in rectangular coordinates, plus 4 would move it up 4. But we're not in rectangular. So 9.3 was conversion. Meaning converting equations from conversions of equations. Like we did x squared plus y squared equals 9. Write it in polar form. Or maybe theta equals pi thirds into rectangular form. Or more complicated, let's see. Say x minus 4 squared plus y squared equals 16. So how do you change this one into polar form? What? Yeah, so we know x squared plus y squared equals r squared. Therefore, what is r? 3. So we can recognize that, say that's the equation of a circle, therefore we know a circle has the equation r equals the radius. So that one's easy. Pi thirds. A equals pi thirds. What does this graph look like? It's a straight line. Where does it go through? 0, 0, which means it's going to be in the form y equals mx. How do we get n? Oh, we know this is pi thirds. What is the coordinate of this point right there? It's just on the unit circle. Okay, what's x equal to? 1/2 root 3 over 2. How do you calculate the slope? Okay, y over x. So root 3 over 2 divided by 1/2 is? Or 0.2 divided by 1/2. So we have y equals root 3x. Would be our equation. Does that make sense how we did that? We first recognize that if it's theta equals something, it's a straight line, which means it's always going to be y equals mx. So it goes through 0, 0. So you got the slope, which is y over x, or delta y over delta x. But if it goes through 0, 0, it's just y over x. This one, a bit more complicated. Changing it to polar form. First, what's the shape? Hey, what? What's the shape of this? Circle. How is it shifted? Okay, right 4. What's the radius? 4. Okay? So, if we were just sketching this, it would look something like this. Where this is 4 to the right, it actually goes through there. What graph does this look like? I mean, what, you heard the polar form? Okay, what? Not quite sine. Remember, where would sine be? Up the top. The sine, when the sine circle is just up here, this is the cosine. So we expect it to be focused on cosine if we're doing it. So now, how do we actually change the form? Well, I would start by probably multiplying this out, get x squared minus 8x plus 16 plus y squared equals plus y squared equals 16. Then what can I do? Okay, 16 cancel. What's x squared plus y squared equal to? Yes, r squared minus 8x equals 0. What is x equal to? R cosine theta. So r squared minus 8r r cosine theta equals 0. I have an r in each part, canceling. So r, I'm going to add 8 equals 8 cosine theta. Wait, no, I sort of have right here, 8 cosine theta. So I need to go into reverse to change this back to that one. Nine point four was about conic sections in polar coordinates. So what's the base form for these? Something like that? Cosine or sine, depending on what you have. And when you have this type of thing, what was the first thing you usually wanted to do? Find E. Why? Yeah, E tells us what shape, because if E is between 0 and 1, it is ellipse. If E equals 1, it's a parabola. If E is greater than 1, hyperbola. So let's see, if we have R equals 9 over 3 plus 2.25 cosine theta. 9 over. So first, what shape is it? So in a test, I might just give you a thing and say, identify whether this is a vertical parabola, vertical or horizontal hyperbola, vertical or horizontal ellipse. So first, what's the shape? Parabola, ellipse, or hyperbola? And how'd you tell?
Greater than 1.
Okay, what is E?
Wait, you don't know that.
We don't know E yet. Why not? Okay, we have, remember, we need the 1 here, so divide by 3. So we'd have 3 over plus 2.25 divided by 3 cosine theta. So it's an ellipse. If it has cosine, what is it, vertical or horizontal? Okay, go on your calculator, figure out. So plug in ER equals this. Okay, it is horizontal because cosine does, remember cosine does x direction, sine would do y direction. So this, we could say, is a horizontal ellipse. Then you have 9.5. So, stuff I may ask, although I probably won't, will be graph on a complex plane. I probably won't ask to do that because it's very simple. What I may ask though is the absolute value of say 2 plus 3i, or say 4 plus 3i. What's this equal to? 5.
Oh,
I can tell. I can tell it's not so quick. Second circle, 3, 4, 5. So like this one, what would you do? So 144 plus 36 square root of 180, which simplifies to what? 6 root 5. I may ask something like this. Given you have 2 plus 4i times 6 minus I, change it to trigonometric form, and then multiply it in trig form. So what would you have to do that? So change to trig form and multiply. So what do we need for trig form? What are the two pieces? R and theta. So first we'd want to say, what is R here? So 2 squared 4 plus 16, 20 squared 20, so 2 root 5. R here would be, okay, x squared plus y squared equals r squared.
oh,
Or a squared plus b squared equals c squared. Where you've got a, b. So 6 plus 1, 36 plus 1, square root 37. And how do you get theta? So first, where's 2, 4? Which quadrant? Okay, first quadrant, so 1, 2, 2, 3, 4. So somewhere there. So we can be inverse tangent of 4 over 2. Do they want to do that? Zero point what? 1.1? Okay. So 1.1, do one more decimal. 1.07? Okay. So 1.07. And for this one? Oh, 107. Okay. 1.11. Okay. Then 6, negative 1, where is it at? Which quadrant? Okay. So 6 right, down 1, so fourth quadrant. So inverse tangent of 1 over 6, or negative 1 over 6. Okay. So once we have this, we've got a formula. Remember, it's V1 times V2 equals R1 times R2 cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Got that in your notebook already? Just plug in everything. simplify a little bit.
We use Z.
Z, this is just Z form, or this is Z1. This is Z2. So then you're just doing stuff in the formula, doing stuff in your calculator, plug this stuff in, check the cosine of it. Should be fairly simple. And of course, how do you check this? Yeah, multiply is doing FOIL. 2 times 6, 12. And then 2 times negative 2i would be negative 2i minus 4i squared plus 24i, and then simplify that. Probably the most difficult parts on there are ones where it says maybe the 6th root of 3 plus I. How many answers are you going to have for this? What? 6. So we go 0, 1, 2, 3, 4, 5. Can't start at 0. And then plug into the formula and simplify a little bit. So make sure when you're looking at the test, you read the instructions, make sure you follow it. It says multiple steps, do all the steps. There's only one step, don't make it more difficult than it is. Because some of these I'll probably say, I decide not to make it more difficult. Maybe I might say, just write it in trig form, not do anything else with it. So make sure you don't make it more difficult than it says to do. Any questions?